Hello friends! Welcome to Coding Garden with CJ. Welcome to Code Katas number 25, the 25th episode. It's going to be a fun time. I actually don't have the katas picked out ahead of time, so if you have any suggestions for katas, feel free to throw them in the chat. If you are not familiar with this show, you can visit github.com/codinggarden/code-katas, and you can see all of the solutions to all of the things that I've solved in past episodes. There's also this nifty little tool here that you can go to where you can filter katas that I've solved. You can filter by a specific queue. You can filter by name. Yeah, you can check that out. Let's say hello to all the people in the chat. Hello, Sul Yemen. Welcome to the stream. And hello, RabbitWorks JavaScript. Hello, Brett Cooper, who says, looking forward to this. Me too. It's going to be fun. Hello, Rodrigo. Hello, Elia. Hello, Data Dev. Hello, Ahmed. RabbitWorks says, shouts to ECMAScript 6. Shout out? Like, you mean ES 2015? I don't know. Hello, Just Some Aussie. Welcome to the stream. Hello, Mladen. Hello, Brian. Hello, Brooking. Hello, Andreas. Oh, it's been a while, Andreas. Welcome back. Hello, Nahuel. It's fun. Hello, Allegrevi. Allegrevi? Cool. As I mentioned, I don't have the katas picked out for today, so we're going to pick them out. And if you have any suggestions, throw them in the chat. Hello, Jason. Welcome to the stream. Let's just do it. Typically, I start out with like a 7Q. So on Code Wars, the difficulty goes from 8Q all the way to 1Q. The higher the number, the easier it is. So let's get warmed up on like a 7. And let's pick one. I have these filtered here by katas that I have not trained on. So these are ones that I've never seen or tried before. Let's take a look. Breaking chocolate problem. Your task is to split the chocolate bar of a given dimension, n by m, into small squares. Each square is of size 1 by 1 and unbreakable. Implement a function that will return the minimum number of breaks needed. Interesting. Let's hold on to that one. Money. Mr. Scrooge has a sum of money, P, that he wants to invest. And he wants to know how many years Y this sum has to be kept in the bank in order for this sum of money to be the amount to D. Okay, so this is just calculating compounding interest. And your task is to complete the method provided and return the number of years as a whole number in order for Mr. Scrooge to get the desired sum. So determine the number of years to reach a particular amount of money. That sounds doable too. What about this one? Reverse words. Complete the function that accepts a string parameter and reverses each word in the string. All spaces in the string should be retained. I actually kind of like this. So you're given a sentence, and you're not reversing the sentence, you're reversing each word in the sentence. And you have to maintain the number of spaces. So notice that there are 2 spaces here. The result also has to have 2 spaces. I like that. Maybe we'll do this one. Any thoughts in the chat? Hello, Yossi. Welcome to the stream. Hello, James Ross. It's been a while for you, too. Welcome back. Hello, my name is Nobody. Andreas says, hey, CJ, solving code until deploy code. No bugs. Are you trying to deploy something right now? I actually really like this reverse words one, because it's a little bit tricky, because you have to maintain the spaces. I'm going to do this one. Let's do this one. Do it. Brooking is saying, do it. Cool. So typically what I like to do is solve it locally. So let's click train here. And actually, let's see if I've done anything like it in the past. So on this side, I can search for Yeah, this is the only kata that has reverse in it, reverse Polish notation, which I've done in the past. All right. Brett says, my bug of the week was trying to format my code by padding zeros. So I used x equals 052, but 052 does not equal 52. It's 42, as 052 means the number is octal. What? And hello, Shonder. Welcome to the stream. Okay, so typically what I like to do is let's bring this down locally. So we're going to create a new file. We're going to call this reversewords.js. I like to name it the exact same thing as the slug here, and that is the name. Cool. Let's throw our function in there. Am I not getting linting? I think I typically have linting in the past. Regardless, let's also bring these example tests. I might set up a linter in this code.katas repo if my linter doesn't kick in automatically, because in the past it has just worked, but maybe I need to configure it. Like if I say a equals 5, that should give me an error. I want it to enforce semicolons. I'm going to set up a linter. Actually, here's what I want to do. In the root folder is where I want to install it, so that way it can be used in all of the other, in all of the nested folders. So let's init this. We're going to install -d, so it's a dev dependency ESLint. Hello, Marcos. Marcos says, what a great channel. Learn and have fun. Good job, CJ. Clean code and easy to follow. I appreciate that. Oh, and hello, Bob's Paradox. Welcome. Briggs says, hello, CJ. That's too easy for you. I typically like to start out with easier ones, but the thing about it, even though it is easy, we can solve it in multiple ways. So probably initially, maybe we'll do like a join or something like that. We could probably solve it with a reduce. There are a ton of different ways to solve it, so that's typically what I like to do. Oh, I forgot my local npm isn't running. There we go. Okay, so we have ESLint. Now I want to create an ESLint file. So I'm going to do npx ESLint --init. npx says to run this, and if this is found in the node modules, it's just going to use that. So that's going to use the one that I just installed. Let's check syntax, find problems, and enforce code style. We're doing typically require and module.exports because we're in Node. We're not using Reactor View. Typically, this is running in Node. I am just going to answer questions about my style. I'm not going to use like Airbnb or anything like that. So use JavaScript. I prefer a 2-space tab, single quotes, Unix line endings, and I like to require semicolons. There we go. Let's see what we got. So I need to fix this because I prefer a 2-space tab. Okay, let's see what happens. If I go in here, we look at this file. There we go. We've got some errors. Let's take a quick stretch before we start to solve this problem. What is this complaining about? Unexpected console statement. Let's allow console logs because this is Katas and we log like crazy. So the rule is no console, and we are going to turn that off. There we go. All right. Yossi is asking about LaCroix. This is not a LaCroix. LaCroix is a brand, but this is bubbly water. This is pineapple flavored bubbly water. And this brand is actually called Bubbly. Before I get started, I'm stalling like crazy. Deda Dev asks, have you heard for Deno, which is a Node.js alternative? I haven't, but that intrigues me, so I'm going to look it up. Deno. Interesting. So the creator of Node.js, Ryan Dahl, created it? And it's all of the things a secure JavaScript TypeScript runtime built with V8, Rust, and Tokyo. What? What? That's actually really cool. I like it. I might check this out. So it's like built into the runtime. You can use TypeScript, and I mean, they were using like import syntax. I guess that's TypeScript, but it essentially supports like ES 2015 module syntax out of the box, whereas regular Node.js does not yet without a featured flag. Cool. Haven't heard of it. Looks really cool. Okay. Brett says Deno is still very beta. Okay, but maybe once it gets out of beta, it'll give Node.js a run for its money, or just an alternative that we could use. Okay, let's do this. How are we going to do this? So I think we need to iterate over the string. I think the tricky part here is what happens if there are multiple spaces, because we could just split on spaces, but we need to restore those later on. So in order to restore them, we need to know how many spaces were there to begin with. I thought of something. So maybe what we could do is, before we operate on the string, we replace all of the spaces with can replace, I don't know, with like multiple underscores or something to denote a single space. And then when we put it back together, we know how many spaces go for each one. This is tricky. Okay, so let's say we need a place to store the reversed words. This is probably going to be like a string, or maybe an array that we're concatenating or pushing into. Then we need to iterate over the string in some way. We could split it on 0 or more spaces, but again, we lose our spacing. Yeah. Mladen has ideas. Let's go to the chat for this. I'm not going to jump into it. Let's see what people are thinking we should do. Mladen is saying we should save indices of spaces and letters. Brett Cooper says, would that count happen if it was split into an array? Yeah, so split, map, reverse, join. So you know what? I'm just gonna do this in a single pass. So I'm gonna iterate over the string, but as we go over the string, we're going to be reversing the words, and that way we won't lose the spaces. That's what I'm gonna do. Okay, so let's say iterate over the string from index 0 to the end. Okay, and now inside, so this is gonna be like a for loop or a loop of some kind, and inside of here we need to say we need some sort of Boolean or some sort of indicator of, are we currently iterating over a word? And if we are, we'll be appending it. So let's say a place to denote if we are iterating over a word. And then inside of here, we're going to need and I guess we'll also need a place to store an individual reversed word, because we're going to like build onto it. I don't know, my mind's all over the place. Okay, so a place to store an individually reversed word. Okay, and here, inside of this loop, we'll say if the current character is not a space, we're going to put it at the beginning, or sorry, at the, yeah, we're going to put it at the beginning of this individually reversed word. So we'll prepend letter to individually reversed word. So we're going to be iterating, and essentially we'll start here, and we have a marker that says we're looking at a word right now. So we're going to take the T and we're going to prepend it initially to the empty string. And then we get to the H and we say, is this a character? Yes, it is. So we're going to prepend it. Now we have HT. Then we get to the E. Is this a character? Yes, it is. So we prepend it. Then we get EHT. And then we get to a space. So if the current character is not a space, do what we just did. Else, we need to append. So we need to append individually reversed word to the whole reversed words, and then append the space character. Something like that. So essentially we get to a situation where we get here and we just reversed the word the. So we want to take that the word and put it into our newly reversed string. Actually, I don't think we need... Maybe we can do it without this individually reversed word. I don't know. I see the chat going crazy. People have ideas. This is going to get interesting here because once we have appended it, if there are two spaces, we don't want to append it again. So I'll just make a note here. Don't append if we have already appended. Okay. I'm gonna check on the chat. Yeah, and hello, Alka. Alka says, a streaming solution. Yeah, so we're looking at each individual letter. Oh, and that's a good question. Alka asks, does the period need to stay at the end? Because if not, then it becomes dot dog. Let's see what they did. Oh, it does. Yeah, so, or sorry, dot god. So the only thing that's special is our spaces. Spaces are the only thing that are going to get appended. Cool. Rabbitworks JavaScript asks, how is the move going? It's pretty good. I probably only have 1 or 2 more loads of stuff to take back over to take over to my new place. This is the last stream I'm going to be doing from my old house. So like after the stream, I'm going to take all my stuff down, bring it over to the other house. It's slow going, but it's good. And hello, the Coding Cat. Welcome to the stream. Yeah, Ahmed is saying, iterate over the string, save the letters in a buffer until we reach a space, then reverse the buffer. I'm kind of doing that, but I'm reversing it as we go. Let's see. All right. This is going to be tricky right here. We might have some other indicator of whether or not we've appended it, but I'm going to keep that there. And then after all of that, we should be done and say return the reversed words. And Andre has deleted a few of his messages. That's okay. I think we can make this work. We'll figure it out as we go. Okay, so a place to store the reversed words. So let's just say let reversed string, initially empty string, a place to denote if we are iterating over a word. I guess I don't know if we need that, because when we reach a space, we know that we're no longer inside of a word. So I don't know if we need that. I'm not going to do anything there. A place to store an individually reversed word. And so let's say let reversed word, and we're going to initially say that's just the empty string. Okay, iterate over the string from index 0 to the end. So we're just going to do a basic for loop. Those of you that are new to JavaScript, you may not know that we don't have to split a string into an array to be able to iterate over it. So in JavaScript, strings have length, so we can create a for loop that goes up to the length. And in JavaScript, we can access a specific character in a string just using bracket notation. So that's why I didn't split it first, because we can just iterate over it, because JavaScript lets us do that. Okay, if the character is not a space, so I'll say if character does not equal a space, then we are going to prepend the letter to the individually reversed words. So here we're going to say reversed word equals letter or character plus reversed word. So that's going to put in this, why is this complaining? Reversed word. And so this will put the character at the beginning every time. So that's going to reverse it as we go along. And else we saw a space, so we need to do something here. Append the individually reversed word to the whole reverse words. Don't append if we have already appended. I think I figured out how to do that. Basically, so here we'll append reversed word to the reverse string. So, but we'll only do that if reverse word is not empty. So we'll say if reversed word does not equal the empty string, then we are going to say reversed string plus equals reversed word. So that's going to put it on the end, and then we're going to reset reverse word. So we're just going to say reverse word is the empty string. So that way, if there are multiple spaces, I mean, technically, I guess I don't really even have to do this check, because if there are multiple spaces, it's just going to append nothing. I think I can actually even, let's just leave it off. We'll do this. And then we also append the space character. So we'll say, actually, we can do that right here. Yeah, so we're going to append the reverse word onto the end with a space, and then we're going to reset reverse word. But if we encounter a second space, we're going to append nothing plus a space on the end again. Yeah, so we should be good to go. That's it. Done. And now we will return the reversed string. All right. Did it work? The quick brown fox jumped over the lazy... Oh, I need to start up Quokka. So Quokka is a tool that I use to run the code inside of the editor. And that looks good. I messed up somewhere. Something's going wrong here. Oh, no. A, B, C. Something messed up. I got a super chat from Robin Tom. Thank you so much. Appreciate that. Okay. Let's catch up back on the chat. Oh, yeah. James Ross brings up something that nobody has brought up. I don't know if I want to talk about it. But yes, I'll just say Dash is no longer with us. It's actually a pretty sad story. Yeah. Dash was my betta fish. Race car backwards is race car coincidence? I think not. Okay, let's see what has gone wrong here. So we have the quick brown fox jumps over the lazy. Oh, we're missing the very last reversed word. I think that's the main issue here. Take a quick stretch. And actually, this is wrong, isn't it? Shouldn't this be... Oh, no, because they're individual words that are only a single letter. But what we forgot to do was append the very last reverse word to the end. Because if we hit the very last word and there's no space after it, we would have never appended it. So I needed to do that. So we get the quick brown fox jumps over the lazy god. Apple, apple, and then ABCD reversed is ABCD because each word is only one letter. And then we have double spaced words, and we get back, I don't know if it shows it or not, double spaced words. I think we did it. Let's just throw this into Code Wars and see if it passes, and then we can talk about other ways to do this. Sample tests. Those pass. Cool. All right, let's think of some other ways to do this. Here, I'm going to just copy and paste it, get rid of all our comments, see if we can make it better, shorter, faster, more succinct. And I guess ultimately, we did not need a place to denote if we are iterating over a word, because the moment we hit a space, we're just resetting that word back to nothing. So that handles it. Okay, so we could do this. I think we could do it with a reduce. It'd be tricky. No, I think we can do this with a reduce. Noel is saying the double space words seem to have one space. I think that's just an artifact of Quokka. So you'll notice that it's logging this, which does have double spaces, but it only shows up as single space. But when I tried it on Code Wars, it did work. So I think Quokka is just removing the extra spaces for some reason. Cool. Yeah, Daniel is saying split, reverse, join. Andreas asked an interesting question. Do strings also have array methods like map and reduce? They do not, which is why typically people split a string into an array first and then use the higher order methods. But what you can do is you can use the function dot call. So you can do array.prototype.reduce.call, and you pass in the string, and JavaScript will essentially make the reduce happen on the string without it having to be an array. And it basically takes advantage of the fact that you can iterate over a string and you can access individual indices just like you would an array. So that actually prevents you from having to split it first. So yeah. Data Dev is asking, why not split on a space, then reverse every word individually and join at the end? Because we would lose our double spaces, wouldn't we? I'm thinking we would. Let's just try that solution really quick. So we'll do, because I think when you split, right now let's just return string.split on a space. What do we get back? Yeah, so the issue, well, I guess not. What ends up happening is, let's see. If there was a double space, you end up with an empty string in the array. That's something I didn't know would happen. So technically, like if there were extra spaces in here, yeah, so if you come across an empty string, you know that it actually should have been a space. So yeah, we can use this. We can work with that. Okay, so we need to split it on a space, and then we're going to map it, because that's going to give us each individual word. And then we need to reverse the word. How do we do that? There is no built-in reverse function for strings. We could write our own. Reverse word takes in a word. You could turn it into an array and then call the reverse function. I'm curious if we could do array.prototype.reverse.call with the word. Cannot assign to read-only property 0 of an object. Yeah, so it's trying to, you can't, because reverse modifies an array, you can't use this way of calling it on a string because it would attempt to change it on itself. But what we could do is split it, then reverse it. So return word.split, and then reverse. So here we could reverse each word. And that gives us, and then actually we need to join it back together. So that's going to give us each word reversed. So that's great. But then now we need to join it all back together. But the issue is when we come across a single space, we actually need to turn it into a double, into an actual space. Or do we? I mean, would it take that into account? I don't know. This thing isn't. Let's say this. Oh. It works. I totally didn't think that would work. Yeah, it works. Okay. Yeah, that works too. So instead of splitting it, Alka is mentioning we could spread it. So that's an ES 2015 feature. So you can spread dot the word into an array, which then allows you to reverse it, and then you can join it back together. So that works. Yeah, string.prototype.reverse.apply it to the word. Could work. Okay. Yeah, so I totally did not think we would get the double spacing back, but because that individual like empty string showed up, when we join it back together, we do get it back. Okay, so that's great. That's an easy solution. But here's something to think about. This solution is one iteration. So we iterate over the input string one time and we're done. No more. That's it. This solution first has to split it on spaces. So to find all the spaces, you have to iterate over the string once. Okay, so that's one iteration. And then for each word, we then need to iterate over the array again so that way we can reverse each word. So that's another iteration. It's not as much iteration because now we're only iterating over the words. And then when to put them back all together, to join them, it has to iterate one more time. So this is like 3-ish iterations, whereas this is only one iteration. So that's something to think about. I want to solve this with a reduce. I think we can do it. Yeah, so Alka just posted his reduce solution in the chat. Yossi is saying, make it a true one-liner and drop the mapping function. Well, technically you'd have to do this. You'd have to say like word like that, and that still works. Yeah. So that like defines the function in line instead of calling the function. Let's show both ways. Cool. Yeah, but let's do it with a reduce. The thing is, I'm pretty sure like we could turn this into a reduce, but we could also turn this solution into a reduce. And I think that's what I want to do. So let's see. Let's start simply. Let's turn this into a for each instead of a for loop. that'll get us a little bit closer. So if we do array.prototype.forEach.call, we want to call it on the string, and then we get a function that's going to give us each character. And then all of this code goes in there. And it still works. Cool. So now instead of a for loop, we have a for each. Easy enough. Now, using that, we can try to do some sort of reduce here. So instead of a for each, we'll use reduce. And now we're going to get our accumulator. In this case, the total reverse string is our accumulator. And we need to initialize it as the empty string. So now reverse string can go away. And ultimately, we want to return that whole thing with the reversed word added onto it. And then each iteration of the reduce needs to actually return the reversed string. Okay. So that still works. Everything's true. We've turned it into a reduce. If we eventually want to make this like a one-liner, we could use default param. So this is it as the reduce call. So we still need this reversed word variable hanging around, so that way, as we're iterating over, we can still keep track of the word that we're reversing. But the reverse string does become the accumulator, so we can incorporate that in. Let's see how we can make this like a one-liner or even smaller. A trick people do a lot of times is to define that as a default parameter. And that'll still work, but now we don't have a variable hanging around. Now we could turn this into probably a ternary. So we need to return... Ultimately, we need to return the reverse string. Let's try to turn this into a ternary. So, and really this kind of has to be wrapped in parentheses. So if character is not equal to a space, then we're going to set the reversed word equal to itself. Else, we're going to append the reverse string with the reverse word plus a space. But we also need to set reverse word equal to the empty string. So let's wrap this in parentheses so we can do it like all in one go, like that. Okay. But this whole ternary needs to actually return the reversed string. So we can use the comma operator. What is this complaining about? Yeah, missing semicolon. So we use the comma operator here to actually return the reverse string every time, and that does it. There's probably a better way. I can look at Alka's solution to see how he's doing it. And then now we can turn this into one big one-liner. So we can do that. We can get rid of the curly brace here. Yeah, we've done it. That's ugly. Let me look at Alka's solution to see how he did it. I'm curious, Alka, did you use multiple comma operators like I did? We'll see. This is Alka's solution. Yeah, this would actually if we use the string.split instead of reduce.call, it would reduce the number of characters a little bit. I'm not worried about that. Okay, so split the string into an array, so that way we can reduce it. P ultimately is going to be our reversed sentence or reverse string, and then n is each character in the string itself. So if n is a space, then okay, and so Alka is actually, I think I saw this, yeah. So instead of having two variables, instead of having reversed word and reverse string, he's using an array as his accumulator, which has two values inside of it, so that the first one is going to be the total reversed string, but the second one is the individual reversed word, and that's how we're holding on to it. So it's an interesting way. Instead of having separate variables like reversed word and reverse string, he's storing both of them inside of an array. That's cool. So if it's a space, then we need to append that word and then reset the string, the word that we're reversing. Otherwise, we need to prepend the letter, and ultimately we're just returning P, which is this thingy. Yeah, good stuff. It's tricky. It's a mind bender. Hello, Daniel Garden. It's going pretty well. The move is it's going along just fine. Rabbit works. Alka, how you got so good? Sweet. Let me see. Did I miss anything else in the chat? Oh yeah. Rabbitworks asks, "Do you have any recommendations for web dev podcasts?" I do. One that I listen to all the time on my commute is Syntax. This is a podcast by Wes Boss and Scott Tilinsky. Scott Tilinsky does Level Up Tuts on YouTube. Wes Boss has tons of video courses and YouTube stuffs. But they put out, I think, like 3 a week. Monday, Wednesday, and Friday, I'm pretty sure. And the recent episode, I haven't finished it. I'm probably like 3/4 of the way through. But Travis, who used to be the host of Dev Tips on YouTube, is on the podcast and is just talking about his experiences and career path and stuff like that. But if you don't listen to this podcast, it's a great one. I listen to it all the time on my commute. I used to listen to JavaScript Jabber. I don't as much anymore. Really, I haven't in a while. But it's also a good one. They tend to have guests on who are either like authors of JavaScript libraries or people that are well recognized or known in the JavaScript community. Yeah, I guess I'll mention that. So like the Syntax podcast is typically always Wes Boss and Scott. This most recent episode does have a guest, but typically it's just them talking about stuff. JavaScript Jabber tends to have a guest, and it's more of like a panel where the panel is asking the guest questions. I think sometimes they may not do guests, but for the most part, they have guests a lot. What else? Scott Hanselman had a podcast. I haven't listened to it in a while because it hadn't been updated, but he made a podcast called This Developer's Life. It takes on a similar format of This American Life, but it's all like developer focused. Curious. Yeah, I think so. The last one that I listened to was Space, so I think this one might be a new one. When did this one come out? I don't know, but this is an interesting one. There are a lot of older episodes that you can listen to, but he doesn't seem to have more recent episodes coming out. Those are the ones that I mainly listen to. I'm sure there are others, but check those out if you have not. Oh, good call. So Alka is mentioning, just real quick, right here, let's do it both ways. Instead of doing array.prototype.reduce.call, you can just create an array in line and then do like that. Cool. All right. I am going to submit this one. Sample tests. Looks good. Attempt it. Cool. Submit final. Is it going? Yeah, it's going. It's just taking a while. Oh, cool. Rabbitworks suggested a podcast called HTML All the Things. Let's check it out. Cool. Is this your podcast? Or is this... I've never heard of this podcast. Looks cool, though. Solutions have been withheld. Since you have not yet solved this kata... What? We've hidden the solutions from you? I solved the kata. Code Wars is broken right now. That's messed up. There's my solution. Attempt. It passed. Submit final. There we go. Oh yeah, the link to the kata. Let me here we go. And I'll make sure I throw it in the README too. I spent a long time on that one. Okay, let's find a 6Q to work on. All right. Oh, well, Rabbitworks is mentioning that HTML All the Things podcast is two guys in Toronto, which is cool. Okay, is a number prime? That doesn't sound very fun. Find the unique number. This is an array with some numbers. All numbers are equal except for one. Try to find it. It's guaranteed that an array contains more than 3 numbers. Wait. The tests contain some very huge arrays, so think about performance. All the numbers are equal except for 1. Okay, I was getting hung up on this. It's guaranteed that the array contains more than 3 numbers. It means the array will be at least length 3. Okay. Yeah, I'm thinking for performance, I don't know. Like, I was thinking like binary search, but that would only work if it was in sorted order. You could do it in one iteration though. So just if you look at every number and you keep seeing the same number, you know that the next number you see that's not a number you've already seen, you're done. And JavaScript can iterate through an array of millions pretty quick. I don't know. That might be fun to do. Let's see what else. Valid braces. I feel like I've done some of these before. Oh, so I've done one with only parentheses. This one has parentheses, curly braces, and brackets. Yeah. Yeah, so this kata is similar to valid parentheses, but introduces new characters, brackets, and curly braces. Yeah, I remember I did valid parentheses on stream, and I made a big deal about it because I thought it was going to be really hard, but I think my solution ended up actually being fairly easy. Basically, you just have a counter and you increase it every time you open and decrease it every time you close. And if it ever goes negative, you know that it's invalid. That might be fun to do. I think we can use the same idea here, but it applies to all 3. But actually know because you couldn't, I don't think you could have a curly brace inside of a parenthesis. I don't know. It's too tricky. Let's do, I don't know if I'll do that one. Okay, sort the odd. You have an array of numbers. Your task is to sort ascending odd numbers, but even numbers must be on their places, so they have to stay. 0 isn't an odd number, and you don't need to move it. If you have an empty array, you need to return it. Interesting. So you have an array. Any number that is odd is going to get sorted, but any number that is even is going to stay where it is. So in this case, 2 and 8 and 4 stay where they are, but everything else gets put into a sorted index. That also looks very tricky. What else? Split strings. We already did something with strings, so I don't know if I'll do this. Complete the solution so that it splits the string into pairs of 2 characters. Sounds fun, but let's do something else. Detect a pangram. What is a pangram? A pangram is a sentence that contains every single letter of the alphabet at least once. For example, the sentence, "The quick brown fox jumps over the lazy dog," is a pangram because it uses the letters A through Z at least once. Case is irrelevant. Given a string, detect whether or not it is a pangram. Return true if it is, false if not, ignore numbers and punctuation. That seems doable. Write number in expanded form. Ooh, this is a math one. So you're given a number and you'll need to return it as a string in expanded form. So for example, if you're given 12, you should return the string 10 plus 2. If you're given 42, you should return 40 plus 2. If you're given 70,304, you should return 70,000 plus 300 plus 4. That's cool. All right, which one should I do? The Coding Cat asks, do you always stream at this time? I used to. I haven't been as regular, but typically Wednesdays, 8:20 p.m. Mountain Time, which is GMT minus 7, is when I typically do Code Katas, and which is what I'm doing tonight. In the future, it will be on a more regular basis, but I've been busy with work and moving and stuff like that, so. Cool. Daniel is mentioning sort and compare the first 2 values. Oh, for for this one, find the unique number. The issue with that, though, is sorting typically takes longer than just one iteration. So for really long arrays, it could take a long time. Whereas if you just do it in a single pass, yeah, worst case is the unique numbers at the opposite end of the array. I guess you could do something smart where you're like zigzagging, like checking, like moving towards the inside, checking both sides one at a time. Okay, which one should I do? We have find the unique number, valid brace. I don't know. This would be tricky. Valid braces, sort the odd, which also seems very tricky. We could probably figure it out, but basically you have to sort but keep certain things in their place. Detect pangram, which actually seems kind of fun. You need to detect if a sentence has every letter A through Z. And then this one, write the number in expanded form. This is more of a mathy one. All right, which one should I do? Any votes? The odd numbers one. 1 vote from Brian. Kelly votes for pangram. Brian changes his vote to find unique number. Here, let me just put these all on the screen at the same time. Okay, vote now with your chat message. Expanded form, but with the decimals. So we have the coding cat votes for valid braces and pangram. Let's tally these up. Okay. Kelly has one for pangram. Brian is going for find the unique number. Coding cat votes for valid braces and pangram. Daniel Garden votes for expanded number. Alka votes for pangram. Bob's Paradox votes for expanded form. Wait, Coding Cat changed their vote. They only want valid braces, so pangram goes down to 2. Nessie votes for unique numbers. That's 2 votes. We need a tiebreaker. Odd number from Kevin. Oh, that's 1 vote. Sean votes for braces. Oh no! We need a tiebreaker. Edward votes for the pangram or sort the odd. You only get to vote for 1. But you could be the tiebreaker, Edward. I might just do pangram. That one seems fun. Pangram. Danielle votes for pangram. All right, we're gonna do it. The fun thing is that means that in a future episode I could do any of these other ones. So you just make note of them and feel free to suggest them, and I can do them next time. Okay, we're gonna do detect pangram. And there is the link. Oh, a bunch of votes came in at the end. I could have done a poll, but there are not that many people watching. We're gonna do pangram, but like I said, the other ones I might do on another episode. Maybe I don't know. I'm gonna do this one right now. Maybe we'll do another 6Q. We'll see. Okay, so we need a new file. Detect pangram.js. Got our function. Gonna bring in our tests. Wait, how are they able to redeclare a variable? That's not right. All right, now we start up Quokka. Okay. So right now our function is returning undefined, so it's broken for everything. Let's use single quotes. Cool. Yeah, Eddie says the undecided voters always show up late when their votes no longer count. It could be that there's a longer stream delay for certain people depending on the internet speed. Yeah. Oh wow, Daniel just suggested something that I think might actually work, and that's a super simple solution. I'm not going to solve it that way to begin with. But let's pseudocode this thing. Okay. So how are we going to do this? So I'm thinking we use the character code values to ensure that we have at least one of every character code. So like if we look at a dot char code at 0. So the letter A is 97. The letter Z is 122. So we need to make sure that every number, 97 all the way through 122, is accounted for. Yeah, so I'm thinking maybe initially, before we iterate over the string, we create maybe an object where it has like, well, I guess we don't really even have to use the character codes. We could just say like, A is true, B is true, or is, I don't know. Yeah, I think it could just be set to anything, because what I'm thinking is every time we encounter a letter, we just remove it from the object. Boom, it's gone. And then at the end of it all, we check to see if we have any left. And if we do have any left, we know that every character wasn't used. That's one way to do it. Yeah. Cool. Yeah, someone's asking like a political question. I'm not going to answer on stream. Try to keep this show kid-friendly and non-political. Okay. Not that being political is not kid-friendly. Those are mutually exclusive, but that's just what I do on the stream. Cool. Okay, so I think I'm going to create an object with every lowercase letter as a property. Then we will iterate over the string. And we will then delete or remove the letter from the above object if it exists. So every time we encounter a letter, we're just going to be removing it from this thing. And then after we're all done, after it's all done, if object has no properties, return true, meaning we used every letter. This is just one way to solve it. There are some really good suggestions in the chat for other ways to do it, and I think we'll get to those. Let's try to do this. So my thought for creating an object that has all of the letters inside of it is just to iterate from 97 up to 122. So let's say let I equals 97, and then it's going to go all the way up to 122. And then we have an object called like all letters. And we'll say all letters at, can you do something like string.from, from charcode I equals true. So if we log this all letters, let's just only run this once. We literally get an object that has A, B, C, D, E, F, G. So it has all of the letters. And now what we're going to do is as we iterate over the string, when we encounter a letter, we're just going to remove it. And at the end of it all, if there are any letters left, that means we didn't use all of them. Okay. And I should remove the letter lowercase letter. So we're doing everything as lowercase. Okay, so let's create a for loop. We're going to go from I to the end of the string. We're going to have the current character is going to be string at that index. And then we just remove it from the object. So we'll say delete all letters at that character. But beforehand, we need to lowercase it. And I don't think this will error, like, if we come across a letter multiple times, like, it just won't, like, if we come across the letter A, we delete it the first time, but if we come across the letter A again, and we try to delete it, JavaScript won't care. It just basically, it's deleting nothing from the object, I think. So that should be good. And now we'll say if object has no properties, return true. So we'll say return object.keys of all letters dot length is equal to 0. Cool. Yeah, we did it. Yeah. Yeah. Yeah, and the coding cat says delete. Is that a real thing? Yes, it is. So delete is a way of removing a property from an object. Let's just see it as an example here in the console. So let's store this object in a variable. So if we look at object, it has 2 properties, B and C. And if I say delete object.b, that will actually remove the property from the object. And now if we look at object, it only has the C property in there. So this is deleting it using dot notation, but you'll notice here where you're just using bracket notation. It's the same thing. So if I said delete object bracket C to grab its C property, that would remove the C property, and now object is just an empty object. So yeah, delete is a JavaScript thing which will actually remove a property from an object. Data dev is saying delete is apparently slow. It might be, yeah. Under the hood, it has to go in, remove that property. I was just thinking this. I would intuit that this is potentially faster than, because I'm storing this in an object. Another thing I could have done was created an array with like A, B, C, D, etc. inside of it. And then if we come across it, find it in the array and remove it. I'm thinking the process of finding it would actually be slower than just directly deleting it from the object. I guess something that we could do is we could create like a sparse array where we know the indices. I don't know, but then I don't know how we would determine if it doesn't have anything in it at the end. I don't know. Cool. Okay, saying delete object. What happens if I try to do that? It's not going to delete the variable. It can't. Yeah, false. It's still there. Cool. Okay, so I'm going to do what people were suggesting in the chat to solve this. Essentially, what they're suggesting is that we create a set from all of the letters in the string. So let's do this. So we'll say create a set from letters in the string. We'll say from only letters A through Z in the string, because we don't want to create a set that has like a period in it or any other punctuation or even spaces. We only want the letters A through Z that are in the string. We're going to create a set. A set is a data structure where no element is repeated. So the cool thing about a set is when you create it, you can pass in something like this, and part of the creation of the set is that it won't duplicate anything. So it'll only create one instance for every letter O. It doesn't create it multiple times. It's only in there once. And then once we've created the set, we just check to see, is the length of the set 26? Because there are 26 characters in the alphabet. So we'll say if length of set is 26, return true. Yeah. Oh, interesting. So totally unrelated, but when I was trying to delete this object here, I did declare it as const, but Alka is saying when he deleted the object, It actually deleted it. But it's probably because I declared it with const. Yeah, and also you should never delete a variable. that'll break your code. Yeah, I think that's the case. I think that's the case, Alka. So if I say like object2 equals that, then I delete object2. Yeah. So if it wasn't declared with const, you can delete it. Weird. Okay. Yeah. So this is super interesting, right? Turn it into a set. If the length is 26, you're good to go. So let's do this. So we'll say all letters will be a new set. I believe, can a set take in a string? Let's just see what happens here. And really, I want to see, yeah, what do we get back? Yeah, so we get a set that has a space in it and it has a period in it, but that still technically works. Cool. But probably what we would do is we could do a match on it to only match A through Z globally. Yeah, so by running a regular expression first, we only pull out the actual letters A through Z, and then we can pass that into the set, which should be a set that doesn't have spaces or periods. Cool. I guess the other thing is, do we actually need to lowercase it? I guess we don't. That's super interesting. So the set, even though I think there are, yeah, there's a lowercase t and an uppercase t, but if we look at the set that it creates, it only has one t in it. Very interesting. Alka is saying we need to lowercase it, but do we? Because do you see the capital T in there? Am I missing it? Oh, I'm removing it with A through Z. Okay, good call. So ideally we should just lowercase it before we match it. Okay, thanks for catching that. So set it all to lowercase, only match A through Z, and then turn that into a set. And does a set have a length? Does it have a count? I think we can do keys.length. How do I find the length of a set? Set. The set object lets you store unique values of any type. Okay, what do we have? Set.size. The size accessor property returns the number of elements in a set object. So right here we want size. Cool. And we want to say if size is equal to 26. Yay! We did it. Cool. Yeah, so I'll paste in the solution that Daniel provided. I think it's similar. Yeah, so create the string, very similar to what we did. Create the set, and then check to see if the size is 26. Cool. Cool. Hiccup Master says, didn't know JavaScript had sets. That's cool. Yeah, they were just introduced, they were introduced in ES 2015, so a few years ago, but most browsers didn't get support for it, I guess, until recently. But yeah, it's a thing. Cool. What other ways could we solve this? Blast Trask asks, am I married? No, I am not. I'm not married. Hello, Ty. Ty says, you are awesome. Keep up the streams. I will do my best. Okay, so the ways we have solved it are first, have something that has every single letter, remove it as we go. If anything's left over, we know that it doesn't have every letter. The other way is to create a set. And then if the set length is 26, we're good to go. What else could we do? We could count all of the unique occurrences of a letter in the string, which is kind of what we're doing with the set, but I mean, we could do it manually. And then if the number of unique characters is 26, we know that it is a pangram. It's essentially the exact same solution as a set, but instead of using a set, we basically build our own, like using an object. Brett mentions, I just recalled another podcast called Tools Day. It has a custom intro song each week performed by the host and played on a ukulele. Yeah, initially, when I started this channel, I wanted to do something like that, where either on guitar or ukulele, I play a new song for every stream. I think ultimately it just ended up being too much work. Cool. I think I'm going to leave it at this. I will submit this solution to Code Wars. Let's see what happens. Sample tests. Attempt. Cool. Submit final. Sweet. Cool. This is an interesting solution. So essentially, they created an array because they split it. So an array of every letter, A through Z, and they lowercase the string. And then for every letter in all of the letters, they checked to see if the string has that letter. And if it doesn't, it would immediately return. I don't like this solution because it has to iterate over the string every single time as it checks each letter. And so the worst case is if the string actually does have every single letter, and that's going to take the longest runtime. Interesting solution, may not be that performant for longer strings. Cool, so match A through Z, case insensitive. That's something else we could have done. I think somebody mentioned it in the chat, but yeah, instead of lowercasing it first, we could have done a case insensitive search, which technically still would have worked. What is this complaining? Why is this complaining? Comment it out. Okay, but if we did this, and we did do a case insensitive search, should still work. Oh no, it doesn't. Would we do A through Z? I don't know. Huh. Weird. Okay. Yeah, this one does the same thing. I think just like index of and includes, like we literally have to search and iterate over the string every single time. I don't like that. That's lots and lots of extra iteration. Yeah, again, if you use index of, it has to search it. I'm curious why this is everyone's go-to. And again, so if you're mixing index of or includes and something like an every or a map, that's basic. Think of that as like a nested for loop. There we go. They did the thing that we did. This is hilarious. How is this even a thing? Find a random number. If it's greater than 5, return true, else return false. This has to be specific to how they wrote their tests for this one. That is hilarious. That is awesome. That's great. Wow, yeah. Okay, let's do one more. We'll do a 5Q. Blast Trash is asking, instead of Code Wars, do you plan to do Leet Code in the future, since it's all the rage for interviews now? I actually haven't heard of it. Leet Code. A new way to learn. Start exploring. Maybe. I like Code Wars. I actually pay for the Code Wars. I think it's called Code Wars Red. It's like $5 a month, and you get higher priority when it's running your tests. Yeah. So yeah, Alka is mentioning if you attempt a solution, like submitting your solution enough, a random number generator would actually work, and that's the last solution that we looked at, which is hilarious. Okay, directions reduction. Once upon a time, on a way through the old Wild West. I don't like problems like this. So you're given a set of directions that someone goes in: north, south, south, east, west, north, west, and ultimately you have to reduce that to what directions did they actually travel from the origin? Because in this case, they went all of these directions, but ultimately they only just went west. For you, west is that way, I guess. Because they went back to the origin. Okay, I'm going to go ahead and rule that one out just because I don't feel like solving it right now. Product of consecutive Fibonacci numbers. The Fibonacci numbers are the numbers in the following integer sequence. Given a number, say product, we search two Fibonacci numbers, f of n and f of n plus 1, verifying that that number times that number is equal to the product. Your function, product fib, takes an integer and returns an array. What? Okay, this is a weird way to do it, but so we want to find the product of two Fibonacci numbers that's equal to 714. Two consecutive Fibonacci numbers. The answer to that is 21 and 34. Those are both Fibonacci numbers. If you multiply them together, you get 714. And so we return the two numbers and true because we get the actual answer. However, if you cannot create this number using two consecutive Fibonacci numbers, you return those two numbers and false. So what is 34 times 55? Wait, what? Wait, what? 21 times 34, 714. Okay. So I think this is the first product that goes over. Yeah, because, okay, I think that makes sense. Because 21 times 34 is 714, and that's an exact match for this case. But if we're trying to find 800, we have to go to the next one because we want it to be larger. But the next product is actually equal to 1,870, And so we know that we can't find two consecutive Fibonacci numbers to equal that. So we return those two numbers and false. Okay, this is interesting. It's a mathy one. I realize I just talked about it a lot. I may not even do it, but cool. Yeah, so some people were mentioning that leak code is actually harder than Code Wars. It probably is because they're like interview type questions, but typically on stream, I'm really only doing like some of the easier ones. A lot of these like 1Q, 2Q problems would take me like an entire day or like take hours for me to solve, which is why I typically don't do them on stream because my stream is only 2, maybe 3 hours. Yeah. Hello, Hippo Viva. They say, great to catch a live stream. You're the best, EJ. Thank you so much. Yeah. Yeah, Alka's saying it goes lower than 1Q. They're called DANs. I've never seen those. I don't know. Yeah. Okay, what else? Perimeter of squares in a rectangle. The drawing shows 6 squares, the sides of which have length 1, 1, 2, 3, 5, 8. It's easy to see that the sum of the perimeters of these squares is 5 plus 8. Wait. 4 times 1 plus 1 plus 2 plus 3 plus 5 plus 8. Cool. Could you give the sum of the perimeters of all the squares in a rectangle when there are n plus 1 squares disposed in the same manner as in the drawing? Hint, see the Fibonacci sequence. This relates to Fibonacci. I guess these are Fibonacci numbers. So yeah, that's silly. It's like calculate the Fibonacci sequence, sum it, and multiply by 4. That's the solution to this problem. Right? Right? I don't want to do that one. What else? Integers, recreation 1. Divisors of 42 are these numbers. These divisors squared are these numbers. The sum of the squared divisors is 2500, which is 50/50, a square. Huh. Given two integers, m and n, where m is greater than or equal to 1 but is less than or equal to n, we want to find all integers between m and n whose sum of squared divisors is itself a square. That's too wordy and mathy. I could probably do it, but it's too wordy and mathy. Gap in prime. All these are number based. Let's filter on the left here. Maybe we do something around data structure. What about, let's see what we can find for games. Ooh, Conway's Game of Life. I've done that on stream before. Not this kata, but I've created a Game of Life simulator before. Okay, implement your own method which will take the initial state as an n by m array of zeros, dead cells, and ones, living cells, and return an equally sized array representing the next generation. Cells outside the array must be considered dead. So, okay. That could be fun. The Game of Life rules are pretty interesting. We'll hold on to that one. Hello, wait, what? In order to stop too much communication from happening, your overlords declare that you are no longer allowed to use certain functionality in your code. Disallowed functionality, strings, numbers, regular expressions, functions named hello world, or anything similar, object keys named hello world, or anything similar. Without using the above, output the string hello world to prove that there is always a way. That's great. That's awesome. I think we can. That would be really fun to think about. I mean, it reminds me of there's an esoteric JavaScript programming language that uses only like square brackets, but you can essentially turn any JavaScript program into that. Yeah. Hello, Felix. Welcome to the stream. The Coding Cat asks, when can you make an Electron app? Eventually, I've done a couple of videos in the past where we made an Electron app. One of them was a Newbie Tuesdays stream. We made an Electron app that was a clipboard manager. So anytime you copy or pasted something, it would keep track of that. If you search my channel, you could probably find it. Yeah, Blast Trash says we should do a 3D Conway's Game of Life. That would be super interesting. I think you'd need to introduce new rules because now a given cell doesn't just have 8 neighbors. It now has 8 and 9 plus 9, 18 plus 8. It has a lot more neighbors, so I think you'd need more rules. Yeah. So we can't use strings, we can't use numbers, we can't use regular expressions, we can't use functions. How would we do it? This is super interesting. I kind of want to do this one just to figure out how we would do it. Yeah, let's just ponder this and like let's play around in a JavaScript console really quick. Like, how can I get the letter H without using strings or numbers or regular expressions? Like, is that even... I mean, obviously it's possible because people have solved it before. What if I did true dot toString? That gives me the string true. How can I get the letter H out of there without using strings or numbers? What if we got the character code? Is there a way to add or subtract without using numbers? Oh, I guess... Yeah. We'd have to, like, plus a bunch. Okay, what is the character code? So we need to this is ultimately what we need to output, hello world. So, like, what's the character code for H? 72. So how do we get to the number 72? If we say true toString, and let's say we take let's uppercase it. True. And let's say we take the first letter and we look at its char code. We get 84. We could we could subtract. Wait. Can we not do that? Invalid left-hand side expression in postfix operation. We could say number equals that. Number minus num. Oh, that subtracts it. Yeah. And then we could keep going until we get to 72. Cool. And now if I do string dot from character code num, we get the letter H. I think we could do this. I think we could use the letters here and then either subtract or add to them to get the characters in Hello World. Okay. Yeah, let's look at the chat because they asked some suggestions. Hello, Mohammed. Mohammed says, CJ, I just want to say thank you a lot for your streams. It has helped me a lot to finally get a job overseas. That's awesome. Congrats. That's great. Oh, and gave us another way to get an H. You do map.prototype.has, I guess, which is a function.name, to uppercase. That's going to give you the letter H. Yeah, we can't use... Oh, I can't use numbers. Yeah, so we can't use numbers or strings. So here I'm using numbers like 0. I couldn't do that. I'd have to find another way to get the 0th index. Okay. You can use plus. You definitely can. Oh, yeah. So that's a good way to do it. So Alka is mentioning instead of using numbers, we could use destructuring. Sean is mentioning bit shifting. And then Kelly is saying E is closer to H. I do want to explain the thing that Alka did because it's actually pretty cool. So here's what he did. I'm gonna keep that console open because it has some gems in there. So if you do map.prototype, so map is a data structure in JavaScript. The prototype is like the object prototype of that type of thing, the map thing. And then has is a function, I believe. Yeah. And then name is the name of the function. So that gives us a string. And then if we make it to uppercase, that gives us has. And then if we destructure it to grab the first letter out of it, now N is the capital letter H, is the letter capital H. Let's figure out how I could do this without using zeros. Would destructuring work here? Yeah, because that gives us a capital T. But then how would I get character code at 0? How can I get the number 0 without typing the number 0? I could create a new array and get the length of it. So t.char code at .length. Oh, sorry, in. Yeah, okay. I think I'm gonna I think I'm gonna do this. It's gonna be really long and really verbose and like kind of dumb. But basically what I need to do is I need to get the character code for each letter in Hello World, and I will achieve that by using the letters in the word, either the word true, or I could also use in the word false. Actually, we could use this trick here to grab the name of a function. Like, what are all the built-in functions in JavaScript that might have the letters? Like, let's look at all the functions on the array prototype, just real quick. Quick stretch. Okay, yeah, I just want to look at the array prototype. We can look at the functions, and I think we can get the function names. So we have array.from, array.every, that could get us the letter E. So if we do array.prototype.every.name, yeah, that gives us the letter E. This is awesome. Okay, let's just do this one because it's hilarious. This is the name of my file. Hello w dot dot dot. Wait. This is great. If I figure this out, I want to I want to make it like tweetable so I could tweet it. So like this is how you do hello world without using strings, numbers, regular expressions, etc. Wait, what? Wait, what? Wait. If we already have a function, oh, the function won't have a name because it's anonymous. I was about to say we could just do like this, something like that. I don't know. So we ultimately need to return the word hello world. Okay. Let's start up Quokka. Right now it returns undefined. So to get the letter H, I'm going to use this trick, which was provided by Alka. So we'll say, and I think we can have variables that like have each letter. So we're going to return H. Cool. So we at least have the letter H. That's great. We want the letter E, so we can do this, but we're then going to destructure the first letter. Yeah, so we have the letter E. That's awesome. All right, we need the letter L. Array.prototype.lastIndexOf. So it's working. It's working. And then we can reuse it. We can reuse that variable. Now we need the letter O. Array.of. Yeah. We're doing it. Yeah, Ty Crenshaw has a good question. How do we get a space? I don't know. We'll figure it out though. Alka has an interest. So array.shift.name. Oh, okay, so you're grabbing the H from shift to be the capital H. Are we breaking any of the rules? So no strings, no numbers, no regular expressions, no functions named, no objects named. Okay. Cool. Yeah. How do we get a space? Let's figure out what's the character code for a space. 32. So can we somehow get the number 32? And also we'd have to do, yeah, 32. I don't know if Brett accidentally typed into the chat, but what is type of nothing? We get undefined. Let's see how far we are. If we have like the letter true and false. So false has the letter A, so we could technically use the letter A. Dot char code at 0. So that gives us a 97. But if it's a capital A, that's a 65. So we're actually closer. So if I do 65 minus let's go the other way. We need to get to 32. So what if I have like the letter Z minus the letter A? That gives us 25. We need to get to 32. So what if I did like a lowercase a? Oh, I just figured it out. So a lowercase a, the character code minus a capital A gives us 32. And then we can use that to turn it into a space. Okay. So that's ultimately what we need to do. We can't do this right now because it's using strings and numbers, but we can figure it out. Like we need a lowercase a. And I think we can get that from false to string. But we want to grab the second letter in false. Do it like that. And then similarly, we could do a dot to uppercase. And then let's just store 0 in a variable. So that's the length of an empty array. So we can use that here. Cool. So this should give us 32. And then we need to turn that into a string. So we could do string dot from character code space. Are we breaking a rule if we use string here? I don't know if they meant string literals. But this worked. We got ourselves a space. Look at that. Yeah, Ty Crenshaw is asking, how does this get the letter A? It's essentially, we're using destructuring. But what happens is when you destructure, you get access to each item in the array, or in this case in the string. So by leaving an empty space there, it basically says skip the first one and grab the second one. So we're basically grabbing the letter A out of the string and putting it in a variable called A. Yeah. I don't know if they're going to dock us for using string dot from character code. But we'll see. Okay, now I need a capital W. Where am I going to find a W? Object.watch? Oh, I think that was like observables. That doesn't exist anymore. Let's see. Copy within. That's a capital W. We'll have to figure out how to get it, but it's array.prototype.copy within .name. So we need to go 1, 2, 3, 4, 5. So we need 4 commas to get the 5th one. There we go. Okay, and then we already have a letter O. Now we need the letter R. Yeah, and that's a good call. So Hiccup Master is mentioning it doesn't have to be A, it can be any letter. So I'm just doing this because it makes it a lot easier for me to understand what the variables are. But this literally could be like X, Y, Z. Like these are just variable names. But because I'm only storing a single character in them, I'm giving them the same name as the character that they have inside of them. So it's just easier to track. Okay. Now we need the letter R. Reverse. Let's use reverse. This is silly. And I think, we already have an L. So now we just need a D and an exclamation mark. Yeah, actually, I want to use the array prototype for everything. Right now, this is using map. Yeah, and I think Alka showed shift. So if we did array.prototype.shift, then we grab the second one, that'll give us a capital H. Cool. Are we allowed to use arrays? Yeah, we are. I think I can do this. Like, create an array, and then we don't have to do array prototype anymore. Yeah, that still works. Cool. All right, we now need the letter D. There's find. And we want the 4th letter. Okay, now we need to figure out how to get an exclamation mark. This one might be very tricky, just like the space was. Oh, it's just 33. Cool. So we can take our space, add 1. Okay, so let's do this. Exclaim. Is that how that works? We'll do space. We need to add 1, but we can't use numbers, so we can do an array with one thing in it that has, and we're going to grab its length. So that should be 33. Yeah. And then, oh no, sorry, not this. I've literally logged 33. Yeah, so that gives us 33. And so here we can do string.fromCharacterCode. We've done it. Now the only question is, will they let us do string dot whatever? Yeah. Yeah, that's a good point, Alka. So instead of putting array everywhere, I could create a new array every time. Like that. Okay. Let's see what happens. Will it accept it? Sample test. You passed. I don't know if the in the final attempt will it detect that we're using string right there. Go. Sweet. It worked. We did it. So this is one way to solve it. Basically, we're using the fact that in JavaScript, it kind of has like introspection. Like you can actually get the name of a function as a string, and we're doing that in pretty much all of these different cases. Like we're getting the name of the function, which gets returned as a string, and then we're using destructuring to like pluck one letter of that function name. And so we essentially created like all of these variables that each have like one character in them. And then we concatenate them all together, which ultimately gives us hello world. Cool. Oh, this is interesting. 1, 2, 4, 8, 16, 32, 64. So I think they grabbed all of the character codes for the letters that they would need. That's super interesting. If you do plus true, that actually gives you back the number 1. And so once they had the number 1, then they created 2, then they created 4, then they created 8, then they created 16. They're essentially doubling each time. So they just start with 1 and then they create multiple numbers. Yeah, and the space is 32. And then they figure out a combination of the numbers to figure out each of the character codes for the letters. That's pretty cool. So instead of using like the function names, so in my solution, we're using basically function names from array functions. In this case, they just created their own functions with weird names and then grabbed letters off of it. This is awesome. So this is the thing that I mentioned earlier. Yeah, it's a bad word. Look away from the screen if you don't like bad words, but it's really funny. So you put in some JavaScript code and it turns it into just brackets, parentheses, exclamation marks, and like plus signs. And if you evaluate this code, this actually runs alert. So what they probably did was this. They did console.log hello world, and then they encoded it, and then they submitted this as their solution. And actually, it's not even a console log. It's just the string hello world. Yeah. Cool. All right, that was fun. Yeah, so Data Dev and Mohammed are all mentioning. So I did space plus the length of an array with one thing in it. You could use plus plus. The only reason that I didn't use plus plus is because plus plus would modify space, and I'm using it here. So technically, like if I store this in a variable, then I could plus plus it afterwards. So yeah, it could work too. Okay. Yeah, that was fun. Oh wow. What a way to do it. So they created all the numbers 1 through 10 using the length of like empty arrays, and then just used all the numbers to add it to create the character codes for each letter. Genius. Genius. Wait, what? How does this even work? Okay. All right, I'm gonna show Alka's solution, and then I will go. Wait, what? Q is a dot push 1. Okay. So A has now length 1. Similarly, we're using the function names to grab them. Then we do some bit shifting. You have to tell me, Alka, what is happening here. So we take Q, which is the result of pushing into A. What does push return? Does push return the thing you pushed in, or does it return the array? Returns the new length of the array. So this technically would return 1. So Q is 1. So we're saying 1 bit shifted with 4? What does that give us? Or with 5? Gives us 32. Cool. So that is our space character. Yep. Then X. And so people were mentioning plus plus earlier. If you increment, well, no, that works. But this is incrementing the value of C, which is 32, which gives us 33. And then that gives us the exclamation mark. Very cool. Well, so Brett just mentioned 33 could be this funky equation. Let's see what it evaluates to. Whoa! What does the tilde do in JavaScript? One tilde? No tilde. I don't even know what that operator does in JavaScript, but ultimately that gives us the number 33. That's great. Motivation Maxed Out asks, what do you think about making code work first versus making it elegant first, but having it not work yet? I'm all about making code work first. And I mean, typically that's what I do when I'm solving code katas. Like, we'll just make sure we can get to a solution, and then we'll try to make it a little bit prettier. We'll use less variables, or we'll do things in a smarter way. But I think for anyone, especially people that are new to programming and like new to solving programming problems, you really just want to get a solution out there. You just want to make sure that you can solve it, and then once you've solved it, you have a better idea of how you can make it more elegant or fix it up. So that's my preferred method. Oh, tilde is math.floor. And 1 tilde is math.ceiling. Very interesting. I've never used that before. My entire house just shook. So I'm going to go check on that. I'm also going to leave the stream for now. Thanks everyone for tuning in. That was super fun. I'm going to push up all of my solutions. Thanks everyone for the suggestions. Yeah, this was a good time. I don't know when I'm going to stream next. So Saturday, I'm actually getting my internet turned on at my new house. Maybe I'll stream Saturday night. I don't know. Maybe Sunday. This weekend, I really am just getting everything in order, and I'll be moving everything to my new house. I'll be totally moved over, so I'm going to do that. All right. Thanks for watching, everyone. Wherever you are in the world, have a wonderful morning, afternoon, evening, or night. Until next time, here's this.